Hi, and welcome to day 2 of section 5.4, Sum and Distance Formulas. We're going to go ahead and look at a couple more examples today of using these sum and difference formulas. And the first way we're going to do that is we're going to go ahead and prove this cofunction identity. This identity is in your table of the trig identities that you should know. And we're going to go ahead and prove this. And we're going to do it using the difference formula. We have cosine here, and then we have difference, so we're going to use the cosine of u minus v. This is the general formula, and in this case, u is going to be pi over 2, and v is going to equal x. So it's just a matter of substituting and then simplifying. So the cosine of pi over 2 minus x is equal to the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times the sine of x. So I go ahead and simplify this. Let's draw a quick unit circle over here, and I'm dealing with pi over 2. That would be right here. My cosine is 0, my sine is 1. So cosine of pi over 2 is 0 times the cosine of x plus the sine of pi over 2 is 1 times the sine of x. And so this term is going to go away, and I end up with the sine of x, which is exactly where I was trying to get to. So I have just shown that this is indeed an identity. Let's take a look at one more problem. And here I have an equation that I'm trying to solve. It says find all the solutions, and that means I need to find values of x in this interval that make this a true statement. Notice that I have sum and differences here, and I'm using sign in this case. So I have a sum with sign and then a difference with sign. Here are the two general formulas that I'm going to use, and in both cases, in the sum and the difference, my u is equal to x, and my v is equal to pi over 4. I'm going to go ahead and make the substitutions and rewrite this whole mess using these two equations, because I don't know what I would do if I tried to solve it in this way. I'm not sure what other strategy I can use other than these sum and difference formulas. Substituting in the first one gives me sine of x. So I'm just plugging the values into this formula right here. So I get sine of x cosine of pi over 4 plus cosine of x sine of pi over 4. That takes care of this first expression. Now I'm going to add to that this difference formula. So I have a plus sign here, and I'm going to just substitute into this equation, and that's going to give me sine of x cosine of pi over 4. And then I have minus, I'm going to write down here a little bit, minus the cosine of x sine of pi over 4. And this whole thing is equal to -1. Looking at this, I see where I have some like terms that I can combine. So for my next step, I'm going to combine my like terms. I have 2 sine x cosine pi over 4 and notice that my cosine x sine pi over 4, I have a negative. So those are, oops, that's a -1. Sorry about that. Those are going to cancel, and so this expression right here is equal to -1. For my next step, what I'm going to do is I know what the cosine of pi over 4 is, so I'm going to substitute that in. So now I have 2 sine x, and the cosine of pi over 4 is the square root of 2 over 2. equals negative 1. When I'm solving an equation, I want to get my trig expression by itself, and then I can find x. So I need to move this root 2 over 2 and this 2 over here. Notice that before I even start moving things, those will cancel. Those 2's, this is just multiplication straight across, so those 2's will cancel. And so now I'm left with sine of x times the square root of 2 equals negative 1. So now I'm going to go ahead and divide both sides by the square root of 2. And then let's go ahead and I end up with, this is going to cancel here, so I end up with the sine of x is equal to the negative 1 over the square root of 2. I don't quite recognize this, so I'm going to go ahead and multiply top and bottom by root 2 over root 2. Multiplying by 1 does not change the value of this fraction, just the way it looks. And now I have the sine of x is equal to negative root 2 over 2. The question that I have to ask myself is, in this interval right here from 0 to 2 pi, so once around the unit circle, where is the sine of x equal to negative root 2 over 2? And from your unit circle, you should remember that x equals 5 pi over 4, and x equals 7 pi over 4. That concludes this part of your lesson. Please bring any questions that you have on this to class, and we will talk about them. Thank you.